Oh yes, we are touching on this topic. So, is the world a flat disk standing on four elephants and those standing on a bigger giant turtle that swims through space? Join me in this adventure. I'm Martin Dorfling from Cataclysmic Science. For some reason, a few people believe that the world is flat and that it's one big giant conspiracy. If this is the case, how would thousands, tens of thousands of ocean voyages be made by people using the sun, moon, and stars to navigate all around the globe through the northern and southern hemisphere? Back in the era of sailboats, there were simply too many people using this data every day to navigate by and prove that the Earth is round. In this video, I'm going to use some freely available software on the internet called Stellarium. This can be found online, stellariumweb.org. In this figure, I draw a flat Earth and I put in the second figure, a black dot 90 degrees above it and connected it with a blue line. That simulates the North Celestial Pole or the star Polaris. So as the Earth spins, that pole remains fixed in the sky. I will show you this example by using my little globe here. So we have our globe, our Earth, and it spins. And this point, right 90 degrees above the North Pole, remains stationary. That's Polaris, the star that we see. If we stand directly underneath it and look 90 degrees up, then we would see that star and it would remain fixed as we turn around. I will simulate this for you on the Stellarium program. Right, as you can see, north is up here. I'm just going to give it a little twist to see the skies better. The equatorial grid, it's going to move around that point. The constellation art, the constellations themselves. And now I'm going to run the time by hour sequence, starting at 6:30. As you can see, the stars turn in a circle in an anti-clockwise direction. Now it's daylight and the following evening. Now, as you've seen in the video just now, that was around Polaris in the northern hemisphere. But the world is not flat as the flat Earth suggests. There's actually a pole on the south also, because the Earth is round and we have a pole on this side, a pole on the other side. And in the figure here you can see I draw the southern point. There's not a fixed star like Polaris on the southern point, it's more open space, but there's the southern cross which moves around that area. So I will show you this movement from the location of South Africa, which is also around the 30-degree angle, the same as Casablanca to the north. South Africa is 30 degrees, Cape Town 30 degrees down to the southern central point that remains stationary. Now I'm switching on the equatorial grid, constellation art, constellations. Just gonna go an hour into darkness. Right, there we can see the crux. We are looking south now. I'm just gonna switch off the constellation art, then you can see the southern cross better. Now I'm gonna start running the time lapse. And as you can see, looking south, the crux, the southern cross is going clockwise around this southern celestial pole in the middle here, where my mouse is. Let me just go to the next night. So this point stays stationary as we look south. With the southern cross going clockwise around it. Now in the two examples that I've shown you in Stellarum now, I showed you how the Earth, if you stand on different sides, if you look this way to the north, you will see the Earth turn in one direction, and on the other way, the sky rotates in another direction. I will show you now the north and south view at the same time. And notice how the stars rotate in opposite directions when looking north versus looking south. And that is due to the round Earth concept. Okay, they start moving. On the left is the southern celestial pole, and on the right is the northern celestial pole, where you can see Polaris. Both are about at an angle of 30 degrees upwards. Notice how they turn, how the stars rotate in different directions. That is around at the stationary pole. The stars rotate different directions around that stationary pole. By looking at the northern and southern celestial hemispheres, you can see the direction that the stars rotate around them will be opposite directions. This would clearly prove in your model that the Earth is a globe and not a flat surface. In the flat Earth model, there's only a northern hemisphere in the world, and they completely ignore the southern hemisphere. If ever they traveled to the south, they should just look up to the stars, find the celestial pole, and see that the stars rotate in another direction around in the sky. Thank you, and see you in the next video.